Good evening, ma'am.
Good evening. Good evening. So, shall I start?
Yes, ma'am.
Yes. So, friends, from yesterday only, I think we started with the parametric test, right? I discussed the t-test, and in the t-test category, I discussed the one sample t-test, and in case of two samples t-test, I discussed independent samples t-test, right? So today, I think I told yesterday itself, today I'm going to discuss the remaining t-test which comes under the two samples test t-test category. Along with that, I'll discuss the ANOVA, right? And I think I shared just a sheet with all of you on WhatsApp group, which we are going to use in case of second type of two samples t-test, that is dependent samples t-test or paired samples t-test. Right, everyone? I hope it is fine.
Yes, ma'am.
Just give me a second. My Wi-Fi is just resuming as there was electricity power cut, right? So I'm just resuming with my Wi-Fi and then I'll start the session. Hello, am I audible? Am I in a meeting? I think I joined from Wi-Fi now. Am I audible?
Yes, ma'am.
So give me a second. I'm going to share my screen with all of you. And then we are starting with today's agenda. Okay, I think I shared my screen. I am presenting the slides. I hope these slides are visible. Friends?
Yes,
slides
ma'am.
are visible? Right.
Yes, ma'am.
Okay. So in continuation with the yesterday's session, I just gave a recap. Yesterday we discussed the t-test, and I think I told you people t-test, the purpose of using t-test is to compare the means, right? When we are interested to compare the significant mean difference, we are talking about the t-test, right? In that category, we have seen one sample t-test where we will be having only the one sample or one group or only the one variable available. We will call about the one sample t-test. Second category was the two samples t-test. In that, yesterday we have discussed independent samples t-test, where I said we need to have two independent samples or two unrelated samples, right? Or two ungrouped samples we need to have. That way, we can compare the mean of the numeric variable in the two different groups, right? And then we can comment whether there is a significant difference existing or not existing. This was the yesterday's discussion we made. Today, in the same sequence, we are going for the second kind of two samples t-test, which is named as paired samples t-test or dependent samples t-test. So, yesterday we discussed independent samples. Today we are discussing dependent samples, right? Other name for that is paired samples t-test. So in this case, when we are talking about paired samples t-test, where we need to have two, what I can say, means if I want to say in a very simple language, I can say, in case of paired samples t-test, we will only measuring single variable, right? And we will be having only one sample, right? So again, I'm repeating, in case of paired samples t-test, we will be having only one variable and we are having only one sample. But that sample we are using 2 times, means the variable which we are considering in case of paired sample t-test, that need to be measured twice for the same sample, right? But there should be some intervention in between. For example, if suppose before starting this particular FTP, suppose I have asked you certain number of questions on SPSS, right? And then after teaching you SPSS, again I have conducted the same test on the same group of people. So in that case, you can say intervention is the teaching here, right? And I'm having the single variable. I want to test the knowledge of the participants on the SPSS. So before teaching them the knowledge level and after teaching them the knowledge level, so variable is one and sample is also one, because for same group of people we are measuring the knowledge level twice. Is it clear to everyone? So in that case, you can say this is known as paired sample t-test, because there will be proper pairing. If I am collecting the data of one person once, I need to again collect the same person data next time after some period of time. So that way there will be a pairing in the scores of a particular person. That is why it is known as paired samples t-test or dependent samples t-test. So you can say here there is a dependency. The knowledge level before and after. So there is a dependency, right? So that is why it is known as dependent samples or paired samples t-test. I hope it is clear, friends.
Yes, ma'am.
Yes, ma'am.
Thank you. Moving ahead, talking about the assumptions of paired samples t-test. So the first assumption says the dependent variable is continuous and it is measured twice on the same sample of subjects. So if you can recall, we have just discussed this thing that we will be having a single variable. That variable will be numeric variable or continuous variable. So that is why we are calling that variable as a dependent variable. And we need to measure this variable twice for the same sample, right? There will be certain time period or there will be a gap of some period of time. And that way you are measuring the same variable twice for the same sample. Second says the differences between the scores of variables
Madam, you are not audible, madam.
Yes, ma'am. You're not audible.
Am I audible now? There is a power cut. Wi-Fi is not
Yes,
working.
ma'am.
Yes, ma'am. You are audible now.
Thank you. So I think I am not switching on my video as I am using my mobile phone data, right? So I'll again share my screen. Okay, so please confirm screen is visible.
Yes, ma'am.
Yes. So I
Yes.
think I was audible till first assumption, right? I think I discussed this. May I
Yes,
come
ma'am.
to the second? Yes, thank you. So the second assumption of paired samples t-test says the differences between the scores of variables are normally distributed. So in this case, that is in case of paired sample t-test, rather than testing or rather than checking the normality of the variable, what we are checking, we are checking the normality of the differences of the scores, right? So as for a person, we are collecting the score twice. So that way we will compare, that way we will calculate the difference on the score of that person, and then we need to check whether the differences which we are calculating are normally distributed or not, right? So this is the second assumption of the paired samples t-test. Third assumption says the differences between the scores of variables should not miss in this particular difference. There should not be the presence of any significant outlier. So the difference of the score should be free from the significant outlier. This is the third assumption of the paired samples t-test. So I hope all the three assumptions are clear and no doubt in that.
Yes.
Yes, ma'am.
Okay, thank you. So moving ahead. Now comes how to formulate the hypothesis in case of paired sample t-test. Generally, we can make our null hypothesis as the mean difference between the variable scores is equal to 0 in total population, right? Or maybe you can say there is no significant difference in the mean of the variable before and after whatever intervention we are taking. So that way we can make the hypothesis. Now I think we are discussing the hypothesis testing from I think last 2 days we have been discussing this thing, right? So you need to understand this thing where I think when we apply the different tests using the different softwares, we are getting so many different outputs, right? But what exactly we need to report? We need to report the test value. In our case, as we are talking about the t-test, so we need to report the t-test value, right? We need to report the degrees of freedom. We can report the p-value. We can report the mean difference. And lastly, the confidence interval of the difference. So these things we should report when we are talking about the t-test, right? So this is about the what I can say, the conceptual aspect of paired sample t-test. If it is clear, please tell me so that we can proceed for the applying of paired sample t-test.
Yes, ma'am. Yeah.
Thank you. So, if it is clear, I think I already shared with all of you the sheet named as math. I'm expecting you to open the sheet which I have provided to you. The name of the sheet is math. Please open it. Once you have opened, please tell me, we can proceed.
Madam, you have provided this sheet in WhatsApp group, madam?
Yes, sir. I hope you people have received it. You have found?
Yes, ma'am.
Yes, ma'am.
Okay,
Ma'am.
thank you. So those who have not having this sheet, I am requesting them, go on the WhatsApp group and please check. We are having, I'll give you a few seconds. You please go, check and download it. Once you are ready, please tell me so that we can proceed. Meanwhile, if you are having any queries regarding what we discussed, you can ask me. Meanwhile, people are opening the sheet. Okay, so are you people ready with this sheet? Shall I proceed?
Yes, madam.
Shall I proceed? Or do I need to wait?
Yes, ma'am.
Fine, thank you. So, if you are having the available sheet, you can perform along with me. If not, you can note down the steps, right? So, firstly, we will talk about the assumptions. So, here you can see in this particular sheet, I provided you 4 variables, grade 1, grade 2, before and after. So, sorry, here I'm considering the first 2 columns, that is grade 1 and grade 2. Suppose these are the marks of the students before teaching them and after teaching them. We want to see whether there is a significant difference in the grades before teaching and after teaching, right? So, first assumption is that we need to check the variable available with us should be continuous or numeric. So, here you can see grade is numeric variable. Quite obvious, we can see the data, right? Second assumption and the third assumption is related to the normality and the outliers, right? So according to the assumptions, we have checked the first one and I think it is clear to everyone, right?
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Fine. Now, if you can recall the assumption, second and third assumption was related to the differences. So we are having the scores available of a same variable for the same sample twice. So we need to take firstly the difference, right? So I'll suggest you for getting the difference, you need to go to the transform tab or transform menu. So click on transform menu, then select compute variable. Repeating again, go to the transform tab and select compute variable. Once you are ready, please tell me. Shall I click on compute variable? Everyone has located this?
Ma'am.
Fine. So I hope you can get a screen, compute variable screen, and it is like a calculator kind of screen, right? Now, if you can see, the cursor is blinking at the target variable section. That means it is asking you to give the name to your target variable. So here we are giving the name because here we are performing some calculation, and as a output of that, we will be having one new variable available with us. So we need to give name to that variable. So suppose I am writing the name as difference. Up to you. If you want to write X, Y, Z, anything, whatever you want, up to you, whatever name you want to give. I have given the difference, right? Some meaningful name I'm giving here. After that, I'm coming in the lower section where all the variables are listed. From here, I'm picking the grade 1 and shifting it to the numeric expression box using the arrow key. Then from the calculator, I'm clicking on the minus. So I selected grade 1 minus, and then I'm shifting grade 2 into the numeric expression box. Done? Very simple, I hope.
Yes, ma'am.
Done. So you need to click on the OK button if you have performed the subtraction, the difference we have got. And then you can see in the data editor window, you can find a new column added with the name difference, right? I hope everyone is getting this. Simple. Shall I proceed, friends?
Yes, ma'am.
Yes, ma'am.
Fine. Now, next is we need to check the normality and the outliers in this difference variable only. So now we are not using the first two columns or the original variables for checking the assumptions. We need to check the assumptions using the outcome variable, which we have just created, right? So go to the analyze, descriptive statistics, and then explore. Done? I hope everyone has got it. Shall I proceed? Friends, say yes or no. May I go ahead?
Yes, ma'am. Yes, ma'am. Go
Yes.
ahead.
Yes, ma'am.
Yeah, thank you, everyone. Click on the difference and shift it to the dependent list box. Done. In the statistics, descriptives is already selected. If you wish to see, highest or the largest 5 outlier and lowest 5 outliers, you can click on these outliers. Click on continue. Click on plots. From here, select stem and leaf and select histogram, and then select normality plots with tests. Done. Shall I proceed?
Proceed, ma'am.
Yeah. Continue and then OK.
Sorry to interrupt, ma'am. Can you please repeat from the second dialog box, ma'am?
Okay. Descriptive statistics, then explore, then shifted the difference variable in the dependent list box. First tab or button I clicked. Here I selected the outliers, clicked on the continue, then selected the plots, deselected the stem and leaf, selected histogram, selected normality plots with test, then clicked on the continue and clicked on the OK. Done?
Yes, ma'am. Now, please.
Done. So if you are okay, ready, you can see now we are having the output. So I hope I can start with the interpretation part.
Yes, ma'am.
Yes. So the first portion is the case processing summary table. There you can find total 359 observations for the difference. No missing value is there. Total is 359. Descriptive statistics, I think now you are used to of it. You can check. First one is the mean of the difference is minus 1.17 and the median is minus 1.19. Not, there is not much difference, right? Skewness 0.243, kurtosis minus 0.63, right? Then these are the 5 outliers, or we can say 5 highest value and 5 lowest value in the difference. Then test of normality, separate section you can see where it is saying the significant value, that is p value, is 0.108, which is greater than 0.05. That means we need to hold the null hypothesis of the Shapiro-Wilks test, which is saying that the variable, that is this difference, is normally distributed. I hope it is clear. I hope it is clear, friends.
Yes, ma'am. Please proceed, ma'am.
Yeah. Now looking at the histogram, if you can see histogram is not exactly but approximately normally distributed kind of distribution we can see here. Going down, looking at the QQ plot, you can see many of the data points are following the fitted line, but there is certain or some deviations for the some of the data points, right? Going down, looking at the outlier, if you can see, the box plot is saying at the lower whisker side there is no circle coming, but at the upper whisker side some circles are coming. So if you can recall, I told you that the circles are the insignificant outliers. That means they will not impact your results that much, right? Although some of the what I can say impact we can find, but not that much. So if asterisks will be there in case of a circle, that means those are your significant outliers. But in our case, we can see there is no significant outliers in case of difference, right? So that means both the assumptions are met here, which we were interested to check, right? Fine. So that means now we are ready to perform paired sample speed test. So if everything is okay, everyone is clear, I hope I can proceed for the paired sample speed test.
Yes, ma'am.
Right. Click on the analyze, go to the compare means and select the paired sample speed test. I'm repeating, go to the analyze, select compare means, select paired sample speed test. I hope I can select. So the dialog box is appearing. Here, shift your grade 1 into the variable 1 box, grade 2 into the variable 2 box. That's all. Only in these two pairs we want to perform paired sample t-test. But if you want to perform on a multiple pairs, you can enter them also, right? Okay, friends. After this, you can select the options and you can check confidence interval percentage is 95%. So I think we are okay with this. We are not making any changes in this. Click on continue and then click on OK. So I hope I can click on OK, friends.
Madam, this paired t-test is possible with only 2 variables, madam?
No, variable is one only. Grade is the variable, but we have measured this twice.
Yeah, so grade 1, grade 2. So can we keep one more grade 3 like that and perform this
That
paired
is
test?
paired t-test cannot be performed. You need to go for, yes, you need to go for other test. ANOVA test will be there. In ANOVA, there is one more category available. Using that, you can perform that.
Okay, fine.
Yeah. So, shall I proceed?
Yes, ma'am.
Yes, ma'am.
Okay. Click on the OK button. Now you can see we are getting the output. So I'm explaining the output. The first section is talking about paired sample statistics. There you can see for grade 1, if you want to see the mean of grade 1, it is 6.0181. For grade 2, the mean is 7.1948. Total are the 359 observations in both the cases. Standard deviation in the grade 1 is 0.48 and in grade 2 it's 0.18 or 188. Standard error of mean is 0.02546 and 0.00996, right? Now we can see the next section is talking about this output is the correlation. So whenever we are talking about the paired sample status, always we are getting the correlation because there is a pairing in the observations, right? So that is why we will get always the correlation value. So you can find the correlation value is 0.007, which is very small, almost negligible, right? And it is not significant also. Usually for the paired sample t-test, this value should be significant, but in our case, as data is a dummy data only, so we can say this is not significant correlation. Final table is the paired sample t-test table. There you can find the mean is coming as minus 1.17667. Standard deviation is 0.51668. Then standard error of mean is 0.02727. 95% confidence interval for the difference is minus 1.2 and minus 1.1. Degrees of freedom 358 and the two-tailed test value is, and the significant value for the two-tailed test is 0.000. So if I want to report the results, I can see this is my t value minus 43.150 and its significant value is 0.000, which is less than 0.05. So anyone who can help me, if the significant value is less than 0.05, what we can do? Yes. Yes. Anyone? I hope I'm audible.
Ma'am, we reject the null hypothesis.
Yes. We are going to reject the null hypothesis, and we are rejecting the null hypothesis, meaning is that we can say there is a significant difference in the mean grade before and after the teaching. Again, you can recall always you are comparing the mean. So that is why I said there is a significant difference in the mean grade before teaching and after teaching, right? This will be our conclusion.
If the significant value is less than the level of significance, madam, so it is in that case, no, always it is the null hypothesis rejected, madam.
Yes, sir. It is a thumb rule.
It's a thumb rule. And one more question, madam. So in the paired samples correlation, no, here we have one significant value. And in paired sample test, we have another significant value, two-tailed. What is the difference, madam? This significance and
every test is this is for the correlation, this is for the paired t-test. So as I said, whenever you are performing paired samples t-test or dependent samples t-test, we will always get that correlation value because there is a pairing in your data. So when we are having a paired data, in that case we are getting the correlation. And I said this is a dummy data, so this value is not significant, but in case of paired sample t-test, this should be significant.
okay.
Right? So their correlation is very poor here, but this correlation should be some good value, right? So that is a significant value for the correlation. This is the significant value for the t-test, and ultimately we are performing t-test, right?
Okay. In some papers, madam, I have seen this level of significance is 0.02. So
that is an assumption of the researcher always, sir. There is no mandate you need to take always 5%. As I said this thing, as I belong to the management side, and in management side we are dealing with the variables like satisfaction, loyalty, perception, attitude. So 5% risk is okay. But if you belong to a field like medical and all, there this risk is very high. You cannot take that risk. Even people are taking 0.1% also. There is no
Okay.
problem, because for each and means it is totally like if you means suppose I'll show you. I'll go here again. I'll perform this, right? Now in the options, I'll come and I'll make it 98.
Okay.
That means meaning is what? Level of significance will be 2%. Fine.
Super. Yes.
It will not impact my results. There will be no change in the. You can see I'm pressing OK. It is generating my results again. You can compare, same value you will get, because there is no role of level of significance in giving you the results. Only you need to compare this value. So now rather than comparing this by 5%, this time you will compare with 2%. That is the meaning.
Okay.
Remaining every value will remain same. There is no role of a level of significance in performing the results, of performing the statistic, ANOVA, and whatever it is. Getting my point?
Yes, yes, ma'am. Okay. Understood.
Yeah. So I hope it is fine, friends. Paired sample test is clear to everyone. And I want this kind of interaction. Please be interactive. Otherwise, I'm feeling very drowsy. I feel like I'm only talking to the screen. Is it fine, friends? May I proceed
ma'am.
for the next?
Ma'am.
Yeah, fine.
Yeah, yes, ma'am.
So we'll go with the next test today. So as you can check the, what I can say, flyer or brochure of the FDP, you have found this thing. This is the ANOVA test, which I think we have kept on maybe 5th, 6th or 7th day, something like that. But what I did, I think I have explained you 2 tests on a one day only. I think yesterday itself we have discussed it, one sample and independent samples together. And I think in flyer we have not kept the dependent samples, but I discussed that today, right? Now we will be having one extra day in this particular FDP. As today I'm discussing one way ANOVA. Although this I need to discuss on Monday, right? So that way we have saved one day. On Monday I'll discuss correlation and regression, and then on 7th day, that is Tuesday, right? I will take means what I can say, some application based thing. I'll means in the last session what I did, last FTP I need to say that I have circulated one Google form among the participants, right? And that way collected the data. That will be strictly to this FDP only. I will not use the data for my research purpose, right? Because what I have done, I have given the satisfaction scale related to the FDP. So that way it is not no use of my research. So if you wish, you can fill that particular link. I'll provide that link on Tuesday, right? And whatever output we will get, means whatever responses you will give to that particular, what I can say, questionnaire, we will use the same for the analysis purpose. So that way you can understand if you are collecting first-hand data by your own, so how you can analyze that, what kind of test you can perform on that. I hope it is clear and fine with everyone.
Yes, ma'am.
Yes, ma'am.
Yes. Fine. So I think I'll proceed with the next topic of the day, which is one-way ANOVA. So when I say ANOVA, ANOVA is what? Anyone? ANOVA stands for? ANOVA stands
Analysis
for?
of variance.
Analysis of variance.
Very good. It's analysis of variance. Just a minute. Yes, I think in just a minute. My screen is not visible, right?
Yes, ma'am.
Yeah. Now? Visible, I hope.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So we are talking about analysis of variance, right? Today we will talk one-way ANOVA. And in case of ANOVA concept, I'll say ANOVA is again a kind of parametric test, right? Which is given by Sir Ronald Fisher. He is the British statistician. So after his name, if you have seen ANOVA, if you have applied ANOVA priorly, you know, or previously, you know this thing, we are representing ANOVA by capital letter F, alphabet, capital alphabet F, right? Which comes from the name of the Sir Ronald Fisher only. So on the basis of his name, we are using F statistic, right? So this particular test is also helping us to find the significant mean difference. So question comes, when we are having t-test available to find the significant mean difference, why we are having the ANOVA? Answer to this question is that as when we talk about the t-test, that is independent samples t-test, in that case, we can compare the mean of two groups only. So what if we are having more than two groups? So that is why ANOVA is there to help us out if we are having more than two groups available and we want to compare their mean, we can use ANOVA test, right? So ANOVA is used to find the significant difference in more than two groups, right? So all the group means will be compared simultaneously together, right? So that is why we are using one-way ANOVA. In this case, again, we will have the same variable requirement. That is, we will be having anyone who can tell me, I think rather than I say, you can, if you can say me, it will be good. How many variables are required to perform independent samples t-test? Anyone? I hope I'm audible. I think I'm in a meeting, right? I hope you can hear me.
Ma'am, two
Yes.
variables. One
Two variables.
continuous, other is categorical.
Very good. Thank you so much, ma'am. So when we talk about independent samples t-test, we need to have one categorical variable with the two groups and one numeric or continuous variable, right? Same variable requirement is there in case of one-way ANOVA also, right? One dependent, that is numeric variable, and one independent, that is categorical variable. Only the difference is in case of independent variables, we will be having more than two groups, right? Important thing about ANOVA is that ANOVA is known as the precursor to the general linear modeling. So that means whenever you are performing regression and all, you are getting the ANOVA table also. So ANOVA table we are using there to identify or to ascertain whether there is a linearity or whether the model which we are fitting in the regression is a good fit or not. So I think this we will talk on the day of regression. I'm not talking this thing. Maybe it can deviate you from the topic. So I can say this thing that in case of one-way ANOVA, you need to have two variables, right? Now, when you need to use ANOVA, generally when we are finding the significant difference among the two or more than two groups, right? Then we are interested to find statistical difference among the two or more interventions or two or more change scores. In all these cases, we can use one-way ANOVA. So, as I said about the variables requirement of one-way ANOVA, I already told you we need to have one dependent, one independent variable. And in this case, the dependent variable should be continuous and independent variable should be categorical with at least three labels or three groups or three samples, right? For example, here you can see, if suppose I want to compare the marks of the students who have studied using the discussion method, audio method, or video method. So here marks can be our dependent variable, which is continuous or numeric in nature. Then discussion, audio, and video are the teaching methods, right? So we can say teaching method is our independent variable. And in that case, we are having three different groups or labels, that is the discussion, audio, and video. So that way we can compare the marks in these three different groups. That is students who studied from discussion, from audio, from video. So what is the mean scores of these students and whether there is a similarity or we can say significant difference or no significant differences existing. So this is a use case of ANOVA. Fine. Yeah, I think example and this slide is
Madam,
clear.
what is the difference, madam? The difference between t-test, independent t-test and ANOVA is that in categorical, the ANOVA should have at least three levels, right, madam?
This is the only difference. T can only compare two groups. If you are having more than two groups available in your independent variable, you need to priorly decide in which two groups you want to compare the mean if you wish to perform t-test. But in case of
if two categorical, yeah, if two categorical levels are there, then we go for t-test, right, madam?
yes,
If more than two, we have to go for one-way ANOVA.
yeah, yes. So shall I proceed?
Yes, madam.
Now comes the assumptions part of ANOVA. First one is assumption of independence. That means the two or more groups should be independent. And I think independence you can manage or maintain only once you are taking one respondent in a one group only. That means if you are collecting the data from one respondent only once, that way you can maintain this first assumption. Second assumption is assumption of normality. So here your dependent variable should be approximately normally distributed in the groups of independent variable. Next is assumptions of homogeneity of variance. So here you need to see that if dependent variable should have the same variance in all the three or all the groups of the independent variable. And then there should be no significant outliers in the dependent variable. So these are the assumptions of the one-way ANOVA. Is it clear? May I proceed?
Yes, ma'am.
Fine. If assumptions of one-way ANOVA are not meeting, in that case, we need to go for the non-parametric test and substitute for the one-way ANOVA in the non-parametric test category is Kruskal-Wallis H test, right? So this test is available, which we can perform. I think this is a repetition of the slide which I already showed you previously for understanding the normal distribution of your dependent variable. So I said previously that although it is not exact normal distribution, but somewhere it is approximate normal distribution of the variable. So if this kind of graph you are getting, you can say your variable is approximately normally distributed. Similarly, as we need to test one of the assumption which is related to the equality of variances or homogeneity of variances. So again, you can recall we need to perform Leven's test. Leven's test is used to check the homogeneity of variances, right? So in this case, your null hypothesis says variance is equal, right? Alternatively, variance is not equal. Then talking about formulation of the hypothesis of the one-way ANOVA. So there you can see H naught is what? Mu, that is the mean of all the groups are equal. That is, there is no significant difference in the means, right? H1 says at least one mu is different, right? Means this is very imperative to understand in case of one-way ANOVA, that ANOVA is comparing all group means simultaneously, right? So if suppose I am having total three groups, group 1, 2, and 3. If suppose group 1 and group 2 mean is not same, but group 2, 3 and 1, 3 is same, even that ANOVA will tell you there is a significant difference. Getting my point? So this is the problem with one-way ANOVA. So that is why you can see its alternative hypothesis saying at least one mu is different. Fine. So if any of the group mean is different from the other groups, even then you will conclude there is a significant difference. Is it clear? I hope it is clear, friends.
Ma'am, I have a doubt. Can you give an example? Like you said that one mean is different. Can you give some small example? Because I'm not able to understand that.
Just discussed the example in the previous slide. Suppose we want to compare the marks of the students who are studying from discussion method, audio method, and video method, right? So there are three groups. So if suppose discussion and the audio method students means are different, but discussion and video means are same, audio and video means are same. In that case also ANOVA will declare there is a significant difference.
Okay, got it, ma'am.
Yeah. Now this is the table which we are making manually also, and even the output of usually for all the softwares is giving such kind of table to us, right? Where we will be having the sum of squares, degrees of freedom, mean sum of square, and the F value. As we are performing the ANOVA using the software, so software will give you the extra value which is significant value, right? So further talking about how to perform one-way ANOVA, I think this is, I'm not discussing, this is what we will perform. So this is the conceptual aspect of one-way ANOVA. One more thing I need to tell you, ANOVA is lacking in one more thing. What is that? It is not giving you the pairwise comparison. As I said, if one of the mean is different from the other group's mean, in that case, the ANOVA will declare this thing that there is a significant difference, right? So in that case, ANOVA cannot help you to compare the pairwise means. So that is a lacking of ANOVA. So to overcome this, in SPSS, we are having the multiple comparison test that is known as post hoc test. So we will see using the SPSS how we can perform that, right? So when to use the multiple comparisons, that is also very important to understand. That I'll explain you using the data itself, right? So if the conceptual aspect is clear, please say me so that we can proceed to perform the ANOVA. Yes.
Yes, ma'am.
Fine. So for this, you need to use the sheet which I provided to you yesterday, named as employee data. I hope you are having the sheet. Yesterday I have provided you in group. Yes.
Yes, ma'am.
I hope everyone is having.
Yes, ma'am.
Okay. So expecting everyone to open the sheet, I provided yesterday named as employee data. In this, you can see I am in a variable view. There you can find I'm having a variable salary, which we have already taken in case of independent sample status. So this variable I'm keeping same. And with this, I'm using a variable named as job category. You can come in the values section of the variable view. Click on the three dots. You can find there are three categories: clerical, custodial, and manager. Then clerical, custodial, and manager. Is it clear? So according to the ANOVA requirement, we are having more than two groups or more than two categories in the independent variable, which is job category. Fine, everyone? Yes. Friends, say something. Is it clear? Everyone has opened the sheet, or do I need
No,
to
ma'am.
wait? May I?
No, ma'am. Actually, we are getting only one category, madam. Zero missing. That's it, madam. In that sheet.
How it is possible? I provided you the same sheet.
Yes, madam.
Yesterday
Same
we were
sheet only.
using.
I'm using it, but
What
I'm
about
getting
the
only.
others? And you can come in the data view and you can check how 1, 2, 3 everything is entered there or not. What about others?
Ma'am, in JobCat, clerical manager and all is there, madam. But in variable view, if I select the three dots, no, madam, I'm getting only missing. Zero equal to missing.
Maybe mistakenly you have used something previously. So that is why there is a change. Otherwise, same sheet we all are having. What about others? Please confirm, friends. Please say something. It is difficult to understand. Any other participant will tell me in their data what it is? Yes. Why people are not responding? I'm not getting it. You need to only unmute yourself to talk to me. Either you people are not listening me. Maybe this can be one thing.
I think I'm only using it.
I think so. Is it possible for you to share your screen, sir? If I'll stop share my screen. Yes.
Through Ultra View, ma'am.
Sorry.
How can I send my ID, madam?
No, I
How,
said
how can I
share
send
your
my ID,
screen.
madam?
Share a screen, not ID. I said to share your screen. Is it possible for you
Okay,
to
ma'am.
share your
Okay.
screen? Can you
Yes,
share?
ma'am.
May I stop sharing? Okay. I stopped
Now I'll
share my
share.
screen. Yeah.
Madam, actually, I'm using mobile and laptop, madam. I'm attending class through mobile and I'm using laptop, madam.
That is why I asked
How
you.
can I send?
In that case, you cannot share.
How to, madam, I send through WhatsApp, madam. Is it possible?
I think I need to go and check. I think it is difficult for me to manage two things simultaneously. And looking at the screen, it cannot help me. No, I want to see the live screen. The image will not work.
Okay, madam, I'll try.
You do one thing, sir. If it is not there, I think there is no problem. No big deal. You can enter by your own. You can define if it is somewhere maybe deleted or something. So you can enter by your own.
Yes, madam. What are the categories, madam?
You can see
Zero
my
for
screen. Zero is missing. Although there is no missing data, but still we safer side 0 is entered as missing, right? 1 is for
Yes,
clerical, 2 is for
okay, madam.
custodial. So in the value you need to write 1. In
Okay,
the
ma'am.
label you can write cleric.
Okay, madam.
Then 2 custodial. Then add. Every time you need to add, right?
Yes, ma'am.
And then 3 manager. And after adding all 3 different value labels, you can click on OK.
Okay, madam. I'll do it. You can proceed, madam.
Fine, sir. Thank you. So if it is entered and everyone, if I don't know how many of you are using, at least Harish sir is using along with me. So it's good. You can check now. If you have done this, now we will proceed for checking the other assumptions, right? So first assumption related to variable types, which we have checked. Next assumption is independency of the observations, that we can say that we have taken only 1% data only once. So that way we have maintained that assumption. Now for the remaining assumptions, that is of normality, outlier, we will go for the analyze option. So go to the analyze, descriptive statistics, and then explore. I think till now everyone is in a position to understand from where we can check the normality, right? Everyone is in a position, right? Click on explore, good. And then I'm resetting this, shifting the current salary into the dependent list, and job category, that is employee category, into the factor list. Done. Shall I proceed?
Yes, madam.
Yes,
In
ma'am.
the statistics, yes. In the statistics, I think now everyone in a position to recall everything. I'll click on outliers, then continue, plots, deselect the stem and leaf, select histogram, and select normality plots with sectors, right? And click on continue. That's all. And click on OK. I hope I can click on OK.
Yes, ma'am.
Yes, ma'am.
Right. So we are getting the output. Now you can check in case of the case processing summary table. If I say we can say we are having the current salary of total 363 clerical staff, 27 custodial, and 84 manager, right? No missing value in any of the group. So the total is coming same. Coming to the descriptive statistics, now you can check the current salary is there according to the three different categories: clerical, custodial, and the manager. If I will talk about the first section, that is of the clerical staff current salary, we can check the mean and the median. So mean and median, there is a difference in mean and median. That means there is a problem with the normality. To ascertain it, we'll check the skewness and kurtosis. These are again not up to the mark. That means there is a problem with the current salary of the clerical staff. Means it is approximately not normally distributed. Going for the custodial, you can check the mean, you can check the median. Almost there is a not that much difference. Going and checking the skewness is minus 0.368, kurtosis is 3.652, little bit greater than 3, and it is near to 0. Maybe the salary for the second category can be, not sure, but it can be normally distributed. For manager, mean and median, there is a difference, right? Skewness and kurtosis is also not meeting the criteria. Going down, these are the extreme values for all the different categories for the salary: highest, lowest, highest, lowest, highest, lowest. Then talking about the normality test for all the three category salary, you can check for all the three category salaries, the significant value is less than 0.05. That means you can say this thing, that the current salary is not normally distributed for either for the clerical or for the custodial or for the manager staff. In all the three categories, the current salary is not normally distributed. This is the conclusion from the Shapiro-Wills test. I hope it is clear. May I proceed, friends?
Yes, ma'am. Proceed, ma'am.
Yeah. Now, going down, histogram, again you can see there is this is positively skewed salary for clerical staff. There is, again you can say, I think there is little difficult to comment on the histogram on the normality of the custodial staff, as we are having less number of data available. That is why these bars are not coming properly. Then for managerial staff, again it is positively skewed. QQ plot you can find positively skewed because this curve is going little upward to the line. Then for QQ plot you can find there is very much difficult to ascertain normality using this QQ plot of the custodial staff. Looking at the manager staff current salary status, you can see the most of the points are going above to the line. That means it is positively skewed. Right now, the trended we are leaving and coming to the next section, which is talking about the outliers using the box plot. You can check. We are having the three box plots: clerical, custodial, and manager staffs. You can check for the clerical there are 2 asterisks. For custodial there is almost 2 asterisks. For the manager there is 1 asterisk. That means total 5 asterisks we can locate here, and that way we can say these are the significant outliers in case of clerical, custodial, and manager staff, right? And these are the case numbers. 218 respondent salary is the significant outlier. 272 current salary is significant outlier in case of clerical, and likewise for the custodial and manager we can read. So that way we can say there is a problem with the normal outlier part of the salary for all the 3 categories. So we have checked almost all the assumptions except one, which is homogeneity of variances or equality of variances, which you can check there only in case of output of the ANOVA, like the independent sample status. I hope till here I am clear to everyone. May I proceed? Any doubt so far?
No, ma'am.
Shall I?
Yes, ma'am. You can proceed.
Fine. Yeah. Thank you, sir. Now, How to perform one-way ANOVA? We go to the analyze, compare means, and then one-way ANOVA. Repeating, go to the analyze, compare means, and one-way ANOVA, and then select it. I hope I can click on one-way ANOVA.
Yes, ma'am.
Fine. So this is open for you box. Now shift current salary in the dependent list and employee category in the factor list or factor box. Done? Shifting done?
Yes, ma'am.
Now, I think you can recall I told this thing post hoc test. This is multiple comparison test. As ANOVA is lacking in the pairwise comparison, so that is why we are having the post hoc test available. But whether we need to apply this or not, I think that we cannot ascertain right now. So click on this post hoc tab. You would be able to see the dialog box which is saying equal variance assumed and equal variances not assumed. So this is the group, or this is equal variances assumed. These tests can apply where equal variance is there. But when variance is not equal, you can apply any of this.
Madam, you are not
Right?
audible, madam. And even I couldn't able to see your screen too, ma'am.
What about others? Please confirm me.
Ma'am, there is disturbance in the
My
audio.
screen is visible or not?
Yes, ma'am. This
What about the screen?
ma'am, screen is visible, but audio is
Fine.
a little problematic.
Audio, I think I cannot have by phone data, and what is not good here. So
Your
Wi-Fi
voice
is not
is
working as
breaking,
there is a
madam.
power cut.
Yeah, your
Yeah, sir.
voice is
Actually,
breaking.
I'm using my mobile phone data. Please listen. I said I am using mobile phone data. As there is a power cut, Wi-Fi is not working. So you need to interrupt me in between if I'm not audible or not clear to any one of you. So from where I need to start, please tell me. From where I need to start? Hello. Hello.
From this
Am I
one,
From
audible?
post talk.
Ma'am, from post talk.
Yes.
Post hoc, ma'am.
Fine. Yes. So I said, I think where is the yeah. So I was telling you we are clicking on the post hoc, but I said post hoc is a pairwise comparison test. But whether we need to go for the pairwise comparison or not, that we will decide later on. But still, I'll show you. Click on this post hoc button. This is showing you the equal variances assumed section and equal variances not assumed section. So these tests you can perform when variance is equal. These tests can be performed when variance is not equal. But if you can recall, we have not tested yet whether the variance is equal or not, right? So that is why we cannot select which test we need to apply on. So that is why I'm not going for the post hoc test right now. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes. Now click on the options tab. Here, select descriptive and homogeneity of variance test. Right? Descriptive and homogeneity of variance test. Done?
Done, ma'am.
Click on continue then and then OK. I hope everyone has got the output. Shall I proceed?
Yes, ma'am. Proceed, ma'am.
Yes. Yeah. You can check. In the first section, we are having the descriptive statistics that is showing us we are having 363 clerical staff, 27 custodial, and 84 manager. The mean salary for the clerical is 27,838, custodial 30,938, for manager 63,977. Standard deviation for all the three categories or all the three category salary is given here. Standard error for all the three groups is given here, and then 95% confidence interval for mean is given for all the three categories, along with the minimum and the maximum salary in each category is given. So this is the descriptive statistics portion. Next comes the homogeneity of variances. So the last assumption of the ANOVA, you can check it from here, right? So you need to go to the first row, which is based on mean. As we are using ANOVA, ANOVA is a parametric test, so that is why we are selecting here based on mean. So in this row, if you can check, the significant value is 0.000, which is less than 0.05. So if you can recall, homogeneity of variance means Leven's test, right? So in that case, the hypothesis was variance is equal. So that hypothesis we are rejecting. That means variance is not equal. Is it clear? I hope it is clear, friends.
Yes, ma'am.
Going down, now we will talk about the ANOVA table. So you can see we are getting here between groups, within groups, for sum of squares, degrees of freedom, and mean sum of square, and the F value and the significant value. So looking at the significant value, you can check the significant value of the ANOVA is 0.000, which is less than 0.05. That means in case of ANOVA, we are rejecting its null hypothesis. So null hypothesis, what I think we have not made it. Null hypothesis will be there is no significant difference in the mean salaries of the three category employees or of the custodial, clerical, and manager staff. Right? Is it clear? This is the null hypothesis, which we are not accepting. So we are concluding there is a significant difference in the mean salary of the manager, clerical, and custodial staff. Done?
Madam,
Clear and clear?
Madam, if I have a doubt, if the values are not normally distributed, so finally it will give this null hypothesis rejection.
No, I'm not getting. Null
Suppose if
hypothesis of which test you're talking about? ANOVA?
an ANOVA only, madam. Any test it may be. So if it is not, values are
Why
not
it is
normally.
not related to, sir, listen, it is not related to the normality. ANOVA is based on the mean
Yeah.
and the
no,
variance. So there is no rule of skewness and kurtosis in that case.
Okay.
So why it is not, means it is not linked.
Okay. Okay. It is not linked.
Right.
Okay.
Normality is one assumption. Your data should be normally distributed. That is one assumption of the ANOVA. So your data should meet that assumption. If it is not meeting, that is a different thing, right? So we have checked assumptions is not met by the data, right? But still we have performed. So ANOVA is based on variance and the mean. It is not related to skewness and kurtosis, right?
Yes. Yes. Thank you.
Yes. So now you can see ANOVA null hypothesis is rejected. That means what we are saying, there is a significant difference, right? When the difference is there, right? That means now we are interested to see as there is a mean difference available in the data. So now we want to compare whether the clerical and custodial staff mean salary is significantly different, or custodial and managerial staff significant mean salary is significant different, or manager and clerical staff mean salary is significant different. So this is now the interest of ours. This is what we want to check. We want to go for the paired wise comparison now. Is it clear? Which we cannot do using ANOVA, because ANOVA has directly declared this thing, the significant difference is existing. But whether this difference is existing in one pair, two pair, or in all the three pairs, it is not set by ANOVA. So we are now interested for the multiple comparisons. And for multiple comparisons, we will go for the post-hoc test. And for post-hoc test, we need to decide whether the variance is equal or not equal. So that we are deciding using the Leven's test, and this is saying variance is not equal. Is it clear? Now you understood? Friends?
Yes, madam.
What about others? It is not like you need to say yes. If you are not getting, you can tell me to repeat or whatever you're not getting.
Madam, these type of tests like Levin's test and some other test you are mentioning now, is it possible with Microsoft Excel also?
I think I showed you. I think you. I don't know you have attended my previous FDP or not. In that F test, F variance test is available to check the variance in the data.
Okay. Fine.
Yeah, F test is available there. F test is for the variance because you can see Levin's test is also we are representing by F. If you have seen in case of independent sample status, it is also represented by F.
Okay.
So F is a variance ratio which is available in the Excel.
Acha. Okay.
Yeah. So now I
Ma'am.
have told you the connection that now, yeah.
Ma'am,
Yes.
actually, I shared my database, madam. This is Harish, madam. You asked me to share my data sheet. Can you perform ANOVA test for that, madam?
I think you need to wait, sir. We have not completed yet.
Okay, madam. Okay. I'll leave it.
Yeah, we should go for the post hoc test right now. After that,
Yes, ma'am.
if type permits, I will take that, right?
Okay, ma'am. Okay, ma'am.
Yeah. So now I think I told you the connection why we are going for the post hoc test, that is multiple comparison test, because ANOVA's results are saying there is a significant difference, right? So now again we'll go to the analyze, we'll go to the compare means, we'll go to the one-way ANOVA. And then from here I click on the post hoc. Now equal variances assumed is not the case. We will go for the equal variances not assumed. And in this case, generally people are using the Dunnett test or the Games-Howell test. So both you can select. If you wish, you can select all four also, right? But mostly used are this Dunnett and the Games-Howell. So this is we have selected. Click on continue and then OK. So you can get the one more extra table named as post hoc or multiple comparison table. There you can see first section is for the Dunnett T3 and next section is for the Games-Howell. So if I'll talk about the Dunnett T3, now I'll compare. Now you can see here we are comparing the clerical staff salary with the custodial and manager. So you can see we are having the significant value in both the comparisons. When we are comparing the clerical staff salary and custodial staff salary, the significant value is 0.000, which is less than 0.05. Meaning is we can say there is a significant mean difference in the salary of clerical and custodial staff. Similarly, when we talk about clerical and manager, so this is less than 0.05. We can say that the salary of, there is a significant difference in the salary of clerical and managerial staff. Now, two comparisons we have made, clerical, custodial, clerical and manager. Only one is remaining, which is manager and custodial. So with this we can compare, this is custodial, this is manager. So in this row, you can find the significant value is 0.000, which is again less than 0.05. We can say there is a significant difference in the mean salary of custodial and managerial staff. Is it clear? Making sense? Yeah.
Yes, ma'am.
Yeah, thank you, ma'am. So if it is clear, I think we can take the data of Harish, sir, if you people are okay with this, or any doubt you can ask me. Yes, please. Any doubt? Sir, you have shared your data.
Yes, ma'am. I shared, madam.
I hope you are there.
Yes, ma'am.
Okay, on
I'm there.
WhatsApp.
Yes, madam. WhatsApp.
I'm just downloading. Yeah, give me and I'm just downloading.
Okay.
Madam, what is the difference between one-way ANOVA and two-way ANOVA when we have to go for one way and when we have to prefer two-way?
One way, we are having only one categorical variable. In case of two-way ANOVA, we will be having two categorical variables. So we will be making three hypotheses in case of. Sorry.
Fine,
so
madam.
In
please.
case of two-way ANOVA, okay. So in case of two-way ANOVA, we are making total three null hypotheses. Say for example, we want to compare. I think in our example, if you will see, just a minute, I'll just start and I'll share. Give me a second.
Madam,
It
your
is
voice is
drilling.
breaking. Huh?
I think, sir, you need to please bear with me as I am using my mobile data. There is no electricity, no power in my area due to the weather.
Okay.
So please bear with me. I think as electricity will resume, I will join for my Wi-Fi, right?
Okay.
Yeah.
So,
So what I was saying, yeah.
Yeah, so you are
Yeah.
saying, madam, one-way ANOVA is for two categorical, and
Yeah.
two-way ANOVAs is for three.
No. One way and over one categorical, sir.
Sorry, one categorical. Two-way ANOVA is for
Two categorical.
two categorical. So in one category, how many levels, madam? In one way, you said 3 levels. Right?
This is not a limitation, sir. This is not limitation.
Limitation, any levels is possible.
Yes.
N number of levels possible, madam?
Usually we will not go for more than 4 or 5. It is difficult for us also, but we can take.
Okay.
Is this a data, sir?
Yes, ma'am. Yes, ma'am.
Okay, you please explain me your data.
Ma'am, actually, it is a database, madam, about the accidents of a drilling and milling operator, madam. Here, I want to perform an analysis based on the date, madam. Here, the variables, madam. Date, hospitalized,
Date.
and yes, madam. Date, even date, hospitalized, and amputation, ma'am. And nature title below it.
I'm not getting,
Nature
sir. Can
title.
you tell me the relevance? What it means? I'm not aware with this kind of data. Can you explain me?
Ma'am,
Hospitalized means the people who have hospitalized on a particular date.
yes, madam.
Is it?
Hospitalized on that particular date. During hospitalized, yes, madam. During hospitalized, if they get a minor injury, they will get a treatment, madam. If not, if there is a surgery, they'll go for amputation, ma'am. Next, below to that hospitalized, it is a numerical data, ma'am. Amputation, and then they will narrate. Yes, ma'am.
You please
And
continue.
yes, madam. And they will narrate the injury, madam, like nature title, and part of the body, and which machine they worked. Source
But
title.
I think that all the things are very irrelevant, whatever you are saying. There is no in relation I'm finding. You need to tell
Madam,
me what is the objective.
Madam, all the 7 are dependent, madam. On that particular date.
No, sir, listen. What is your objective? What do you want to find?
Madam, I want to find year-wise the accidents occurred, madam, on particular machine.
But sir, see, my point is that suppose this is your event date. On this
Yes,
date,
ma'am.
something has happened, suppose, right? So the
Yes,
people who
ma'am.
are hospitalized, now doctor
Yes, ma'am.
will diagnose them whether they are fit or not, right? Or they need
Yes,
to
ma'am.
be hospitalized for the next procedure or not. This is what you are saying,
Yes, ma'am.
right?
And then, yes, ma'am. You can proceed, ma'am. Proceed.
And then amputation is the next process. In this process, what the doctor will do?
They will cut off the particular part of the body, madam.
Okay. And then next comes nature title, I think.
Yes, madam. Nature title.
What is nature title? Hello, I hope I'm audible. What is nature title?
1 minute, ma'am. Madam, whether amputation or injuries, sore pains, fractures like that, madam.
But sir, you're not getting me. I think you have to be very clear all the 7 variables, how you can take simultaneously.
Yes, ma'am.
So you
Is
need
it
to
possible,
define
madam?
your hypothesis in a very proper manner. And that way I can tell you which kind of test you can perform, because everything is very different. First thing, event occurred. Okay, we assume, right? So we are assuming that we have taken the data only on that the event has occurred. Is it quite obvious, right? Yes or no?
Yes,
right?
yes, ma'am. Yes, ma'am.
That means there is no role of date right now, because we are assuming on this date any event has occurred. Fine.
Yes, ma'am.
Right. Next. Next comes, now if you wish, means it is like on a different variables, so you can perform different tests. There is no linkage, whatever you are saying, according to me, right? If you want to compare, as we are, again, you can see there is a data. When I will look
Yes,
at
ma'am.
your data, there is a data according to, if I can say this is a month-wise data. So rather than
Yes,
keeping it in
ma'am.
a date, you can keep it in a January. January 3 dates are, I think, visible to me. Similarly, for
Yes,
February
ma'am.
3, for March, there are so many dates on that the particular event has occurred. So that way, you can compare. You can compare the number of accidents or number of
Yes.
hospitalization on the basis of months. This can be the one thing. So that way, you can
Yes, ma'am.
see, can say this thing, whether there is a significant difference in the month-wise hospitalization on in the number of accident cases or not. That you can comment.
Yes.
This is the one thing you can
Yes.
perform, according to me, right?
Yes, ma'am.
Going to the next, after hospitalization, as you want to say this. So 01 is what? This is categorical data.
Yes, ma'am. No, ma'am.
Then
It is it
01
is
is
the
what?
data of a patient, madam. It is a patient. 01. It is a number, madam. Either it may be 1 or 2, like that, ma'am.
Means number of patients who have gone through
Yes.
this process, is it?
Yes, ma'am. Yes, ma'am.
I think at max it is 1 only. There, I haven't found any 2 coming here. Confirm it is that only,
Yes, madam.
or it is
Yes,
like,
ma'am.
or it is like no and yes.
No, it is not a categorical data, madam.
It is clear a number.
Yes, ma'am. It is a clearly a number, ma'am.
But the problem is that I think I can go down. I have seen only there is 0 and 1 coming. No 2, 3, any other number I'm not observing. Only 0 and 1. Miss, just a minute. And there is one more problem. If I will look
Yes.
at your data, you can see
Yes.
there is no hospitalization, but still
Yes,
there
ma'am.
is amputation. Why so?
He might be undergone some surgery like that, madam.
In that case, your objective is little different. Here it should be 1, no? According to me, if you have hospitalized on the same date, only then another person is going for the amputation. No?
Yes, ma'am.
Have
You
you
can
checked
check
the
that
data?
final narrative here, madam. Here, narrative. They have given it clearly, madam. And based on this, we have taken a data, madam. If they are hospitalized, we are if they diagnose with that date, we are putting that 1, madam. If not, if they undergone any surgery on that particular day, how many patients? That number we are giving in amputation.
So hospitalization is a categorical data, is it?
That to a number, ma'am.
That to a number.
Yes, ma'am.
But when it is coming 0, so amputation can, how amputation can be 1? Means that is little difficult for me to understand.
Madam, you can then you can check on this. So, madam, my objective is that in that particular year, in that particular or in that particular month, in
Hello?
that particular mission. Yes, ma'am.
Yes.
I'm audible,
Yes,
madam.
yes.
Yes. On that particular month, and the particular date, on the particular mission, while they're working, they got
I suggest
hospitalized
you,
or accident.
just a minute, I think it is difficult for me to understand as I'm not from the field. What I suggest you do one thing, rather than keeping
Yes,
the
ma'am.
data date wise, you can complete the data month wise.
Okay, ma'am.
Convert it into the January. In the January month, how many hospitalization are there, how many amputation are there, and whatever numbers are there. And that way, that
Okay,
will
ma'am.
be little meaningful for you, right?
Okay,
And
ma'am.
then
Okay, ma'am.
according to the month, you can go for the comparisons. Hospitalization, you
Okay,
can
ma'am.
say how many, means whether there is a significant difference in the month-wise hospitalization, right? That
Yes,
will
ma'am.
be fruitful to say. If you are finding the significant difference is coming, and that way you can check the mean in which month most of the hospitalization have been occurred, and that way then
Yes.
company can make some strategies why the main or most of the hospitalization have been occurred in a particular month. So that way company can make some strategies. What is the reasons
Okay.
why hospitalizations have occurred in that month, and like that. Is it clear? Similarly,
Yes, ma'am.
then you can go for comparison of the amputation according to the month rather than keeping
Okay.
on date. It is little difficult in that case. So that way you will be having total 12 categories.
Yes,
Getting
ma'am.
my point. But thing is,
Yes, yes,
when I will look, just a minute. This is the data of how many years?
10 years, ma'am.
Oh my God. In that case, there will be so many categories. January 15, January 16, January 17, right?
Yes, madam. Madam, here the problem is every day the different accident will occur, madam. So we cannot combine it and we cannot give a final narrative to that the patient, that
In
accident,
that
madam.
case, sir, why you need to perform statistics? Rather than performing it through the statistical data, can you perform this using the graphical representation? That is also meaningful.
How then how to do, madam? Graphical
I think graphically you can go on Excel and you can perform the show the through the clustered bar and all that you can do. So it will show you the January comparison, then a February comparison, then March comparison. So that way some meaningful thing you can take out from that.
through SPSS we can do it, madam.
No, I think Excel is sufficient for performing that. And then why you need to come here in this SPSS?
Madam, one of my guide suggested to go
This is
to
your PhD
SPSS.
data.
Madam?
This is your PhD data.
Yes, ma'am.
I was thinking this is your data related to your workplace.
No, ma'am. Actually, this is my PhD data, madam. I'm a
Okay.
research scholar.
Okay. So what he suggested to you?
Madam, he suggested me to perform the analysis in SPSS. Madam, actually, I'm unaware of SPSS. One of my guides suggested this platform. So only I'm asking.
The problem is that I understand your point and whatever you're saying to me, but problem is that your data is very scattered. Or maybe if you can somewhere compile this data according to the particular type of injury and all.
Yes,
That
ma'am.
way you can come to some conclusion because there are so many different categories available. If I'll go according to the January means month wise, even then there will be 1 month categories and 1 year categories and second year. Then so it is difficult for you to compare, no?
Yes, madam. Madam, but I can tell, madam, for my objective,
Hmm.
I need only 7 variable out of this, madam. That is date, hospitalized, nature title, body part, and event title, source title, and amputation, madam.
But
Madam,
nature
is it
title
possible,
is a
madam?
kind of nature title is a categorical data, right?
Yes, madam. Yes, madam.
Hmm.
Here
Part of
I'm
body is
getting
what?
stuck, madam. Yes, it is a
Part of
categorical
body is
data, madam.
what?
Yes, madam.
Part of body is what?
Where they got injured, madam.
No, that is part of body title. Part of body is again one variable.
Madam,
Numbers.
that is number, madam. It is company, madam. For each and every injury, there will be a number, ma'am.
Means it is a coding of the injury type.
Yes, madam. It is
So
a
there is
coding of.
no use of this data.
Yes, madam.
Okay. And then?
And then even title, madam. Even title.
But sir, these things cannot be interpreted using SPSS also. I think if I will read caught in running equipment or machinery, unspecified other fall to lower level is unspecified contact. Every problem is a different problem. How you will code it? How you will go for the analysis in this case?
Then,
There are multiple categories are there.
Yes, ma'am. That is what, madam.
Yes, so in the multiple categories case, it is very difficult for performing any statistical test and come to the conclusion.
Then which test I can do?
I
When
told
which
you
method I
rather
can adapt?
than going for this, graphical representation will be better. But I think as I suggested you, if you will go for January month data, suppose, or that is also difficult for you to compile because every particular date, the injury type is different. So that again
Yes,
you
madam.
cannot compile. It is very difficult for performing the statistical analysis here.
Madam, for example, madam, for that particular date and that particular mission, hospitalized and amputation is occurred. 2 numerical data and 2 categorical data, madam. Is it possible to analyze, madam?
Again, repeat again the name of your variables.
Madam, date,
Okay.
hospitalized,
Mhm.
and source title.
Source title. Source
Yes, madam.
title, where it is?
At the last, madam. At the last. In which machine they got accident? Source title. Yes,
But
madam.
again, there are so many categories.
Yes, madam.
Multiple categories are there. How you can perform? Have you counted how many categories are there in source title? One is machine, milling machine, then boring, drilling, planting.
Seven types, madam. 7 types.
7 types.
Yes, ma'am.
Only 7 types.
Yes, madam. That will
Okay.
be keep repeating it, madam.
Okay, that means source title is your one variable. Fine.
Yes, madam.
Hospitalized, amputation, second variable, and event date, 4 variables.
Yes, madam.
But problem is that the event date is making problem for you, na? Event date is having so many different categories. Every it is according to the date. Is it compulsory for you to consider the dates?
Yes, ma'am. Then only I can plot graph, madam. Then only I can
Plot you can,
compare.
graph you can plot, but for analysis also need to consider this date.
Yes, ma'am. Is it? Can I skip it, madam? Hello, madam. I'm audible, madam. Am I audible, madam?
Am I audible?
Yes, madam.
Hello.
No,
Again.
no, ma'am. Your voice is breaking.
So power cut is there again in mobile phone.
Madam, you are not audible, madam. I couldn't able to hear you, madam.
Power cut again. Hello.
Madam, I couldn't able to hear you, madam. Your voice is breaking, madam.
Hello. Hello.
Hello, ma'am.
Sir, am I audible?
Yes. Now you are audible, madam.
Yes. Yes. So, sir, the problem is with your that event is
Yes, madam. Even date.
getting me.
Yes, madam.
It is problematic for you, sir, because this will in that case it will be each and every it is a one category for you. Total it is what
Madam, you are not audible, madam.
help us. There is a power cut.
Yes, madam. You can explain it tomorrow also, madam. No problem. By the time I can
It is
sort that data, madam.
explain your data, sir. Sorry.
Madam, I couldn't able to hear you, madam. You can explain me tomorrow, possible, madam, if possible. Or you can give any suggestion to me, madam.
Yogi, data is very difficult for you to keep. So data will go whatever number of days. Am I audible?
No, ma'am.
I think we can. Yogi, audible? Hello. Sir,
Madam, you are not audible, madam. Your voice is breaking.
sir, I think you please understand it is I am using my mobile phone.
Yes, madam.
Hello.
But I couldn't able to see your screen too, ma'am.
Hello. Hello.
Yes,
Hello.
ma'am. Yes, ma'am.
I think, sir, we will discuss this later on. I'm using my mobile phone data. If it is not audible,
Sure,
I think
ma'am.
we
Sure,
cannot
ma'am.
go.
Sure,
Right?
sure, madam. Sure, madam.
Yeah.
We can discuss later, ma'am. Thank you, ma'am. Thank you for
Thank
sparing
you
your
so much,
time.
sir. Thank you, everyone. Thank you. Yogi, sir, are you there?
ma'am.
Thank you, sir. Thank you, ma'am. Yogi, sir, are you there?
Thank you, ma'am.
everyone.
Thank you, sir.